Hi folks, it's Professor Mill here. I want to talk about categorical propositions. This is part 3 of my lecture, and this will be on conversion, obversion, and contraposition, which I will explain in the course of the lecture. Um, as I've said before, the logicians of history determined that there are only 4 standard form categorical propositions. The A, which says that all members of the subject class are members of the predicate class, like all dogs are mammals. Every dog is part of this dog class, and every dog in the dog class is also part of the mammal class. Then there's the E proposition, the universal negative. So the universal affirmative and the universal negative. Universal negative says that there are no S which are P, no S are P. So that would be, you can fill in a word there, no dogs or cats. All right, so no dogs or cats. That means all the members of the dog class are in this circle, this category. And if you put them next to the cat class, they don't mix. They don't mix. There's nothing in between them. And then there's the I sentence, which is the particular affirmative, which says that some S are P, some subjects are predicates, some dogs are beagles. Okay, and then that means that among all the dog class, not all of it, but one small subset is part of the beagle set. Okay, and then there's the O statements, O propositions, which say that some things are not, some S are not P. So in other words, some dogs are not beagles. So that means if you have the whole set of dogs, not all of them, but some small subsection are not beagles. So you got dogs, you got beagles, and there may be some dogs which are beagles, but there are some dogs over here in this other area right here which are not beagles. Okay, so that's the difference. A, E, I, O. I talked about this in my previous lectures. Now I want to move on to conversion. From the time of Aristotle through the Middle Ages and beyond, logicians have concerned themselves with the question of, well, if you know that certain categorical statements are true or false, what does that say about uh, related statements which have similar terms or the same terms, but in different order or different quality? In other words, positives and negatives. And so, what they've done over the many centuries is to try different conversions and obversions. Let me explain what they are. A conversion simply means you take a statement and you switch the subject and the predicate. Okay, so if you say all dogs are mammals. So if we look up here, well, hold on a second. To say all dogs are mammals, to switch the subject and predicate would be to say that all mammals are dogs. So what I want to do here is look at the Venn diagrams and show you which conversions have the same truth value. Because this is the thing that they were looking at. What are the immediate inferences? What are the immediate inferences, or what are the truth values that you can determine when you have the converse or the obverse or the contraposition of a different statement? Okay, so here we go. I'm going to start with E, and the reason I'm starting with E is because the converse of an E statement has the same truth value. Take, for example, no SRP. And again, let's try something simple here. No dogs are cats. Okay? No dogs are cats. So we'll put D and C here to make it more clear. No D or C. No dogs are cats. There's the dog category. That's the cat category. And you see the middle part right there in the middle is shaded, meaning there's nothing there. There are no dogs which are in the cat category, and there are no cats in the dog category. On the other, so when you convert it, you simply switch the terms, dogs and cats. So no dogs, no cats are dogs. No cats are dogs. So here we got dogs again and cats. And we see no cats are dogs. So the middle section again is cloudy. It's covered. It means there's nothing there. It's blanked out because all the dogs are on one side and all the cats are on the other. So the converse of an E statement has the same truth value as the original statement. All right. Now, moving on, we go to the I statements. And again, I'm doing this because the I statements, like the E statements, have the same truth value. So some S are P, some P are S. Let's say some dogs are beagles. So we'll put D and B here. D and B. Dogs and beagles. So some dogs are beagle dogs. So you have dogs here on the left side, and you have beagles on the right side. And you see where they overlap, you put an X, meaning that there is at least one dog, which is a beagle. Of course, we know there are many more, but what this means is there may be dogs out here, but there's at least one dog or more which are in the category, in the area where the two things overlap, meaning that some dogs are beagles, in fact. So when you switch it, when you make the converse of that, some beagles are dogs, you find it's the same thing. Because here's the beagle class, and here's the dog class, and there's at least some beagles which are dogs. Of course, we know that all beagles are dogs, but I guess there could be a beagle horse or something. But uh, anyway, we know that at least one beagle is a dog. Now, of course, we know, in fact, that all beagles are dogs. But the point is the truth value of the converse is identical to the truth value of the original statement. So maybe I should have said some dogs are black. Maybe that'd be a little bit less fuzzy here because you say some dogs are black, meaning there's a black dog somewhere in the black. Among the dogs, there's at least one who's in the black area, and among some beagles, there's some black things. There are some black things which are dogs. So some dogs are black, some black things are dogs. It has the same uh, structure in the Venn diagram. That means these things have the same truth value. Okay, moving on to the A statements. All S are P, all subjects are predicates. And the converse would be all predicates are subjects. So again, if we look at dogs and mammals, all dogs are mammals. The dogs over here, there are no dogs outside the mammal category because all dogs are mammals. So again, we're going to put D and M to use some real things here. All dogs are mammals. So in the dog class, there are no dogs in the left side because all the dogs are within the mammal circle. So not all mammals are dogs, but all dogs are mammals. Now we change it here. We see the converse is that when you say all mammals are dogs, it doesn't have the same truth value, right? All mammals are dogs, because that would mean that there are no mammals outside the dog category, meaning that the only mammals that exist are dogs. That's not, this is not the same truth value as this. So therefore, we can say these, the E and the I have the same truth value, but the A and the O have an undefined truth value. In some cases, they both could be true if they're one's true, but it's undefined. And the O is the same situation. Some S are not P. So some dogs um, are not trained. Okay, some dogs are not trained. When you diagram that, you see in the dog category here, some dogs are not trained. You see the X here, meaning that in the trained, among the trained things, there's some dogs outside the trained circle. So there are some dogs that are trained, but there are other dogs which are definitely not trained. And when you say some trained things are not dogs, that may be true, but when we diagram it, it's completely different. So that means some trained things are not in the dog category, which is different from this one. So there may be, as I said, sometimes this may be true. Obviously there's some trained elephants and trained horses and things which are not dogs. So from a point of view of like inductive reasoning, we look around and we see that there are things which are not trained, which are also not dogs, but or some trained things which are not dogs. But when you look at the Venn diagrams, you realize that the relationship here is not one which is of the same truth value. It's undetermined. It's an undetermined truth value. So if you say that it is, if you answer on a test, oh yeah, the converse of oh is the same truth value. No, that is what they call illicit converse, illicit conversion. So don't do that. You should understand. So with conversions, the E and the I have the same truth value. The converse has the same truth value as the original statement, but not so with the A and the O. All right. So that's part one of this. This is lecture part 3. But that's the first section of the third lecture here. Now we go on to obversion. Now, okay, in order to understand the obverse, what you do is you change the quality. You change the quality and then what you do is you change the predicate. You change the predicate, you replace the predicate with the predicate complement. This is really, my writing is not very good. Let me try this again. You change the quality and then replace the predicate with the predicate complement. Now, what does that mean? Well, equality simply means a positive to a negative, negative to a positive. So instead of saying all such and such, you say no such and such. Or instead of saying some are, you say some are not. And I want to look at my notes here to make sure I get the diagrams down perfectly right. I don't want to make any mistakes because I don't want to confuse anybody. What this means, and this is the good news here, is that when you're talking about obversions, the obverse of any statement has the same truth value as the original statement. And if you look at it, it's very clear after a minute why that's so. So take the A statement. All S are P. So draw that. Again, you put some shading here so that everything in the S category is in the P circle. And so to make it to the obverse, you'd say no S are non-P. Now, what does that mean? It means non-P means anything that's not P. So say we're saying, okay, let's go back to dogs and mammals. If you say all dogs are mammals, okay, all dogs are mammals, then what that means is that there are no dogs outside of this part of the circle where the mammals are. Okay, and the reason I'm doing this, writing this, it may seem painfully slow to some of you who are sharp, but on the other hand, I'm trying to make it clear that one way you can understand these categorical propositions is by substituting real things in there to the S and P's or the A's and B's or whatever letters they're using so that you can understand more clearly for yourself what it means in terms of the relationship. So if you say all dogs are mammals, then you say no dogs are non-mammals, what does that mean? That means this is the mammal category here. Then over here is anything that's not a mammal, and there are no dogs there. In the dog circle, there are no dogs where outside the mammal category. When you say non-mammal or non-whatever, it just means everything which is not a mammal. It could be a fish, a dinosaur, an asteroid, the moon, whatever. Anything which is not a mammal. So when you say no dogs are non-mammals, it means there are no dogs in the dog category which are outside the mammal category. So when you look at it from a Venn diagram, the two things are identical. That means that the converse of the obverse of the A proposition has the same truth value as the A statement. And you're going to find it's true for E, I, O, and U. I mean, no, there's no U, sorry. The E statement says that no dogs, I'm going to cut the chase here. No dogs are cats. And so the way we do that is we put the dog circle in the cat circle, and in the middle is dark because there's no dogs in the cat circle, there's no cats in the dog circle. The obverse is that all dogs are non-cats. Okay? So again, you have dogs, you have cats, and the dogs are over here, the cats are over there, but there are no dogs. I mean, all dogs are non-cats, which means these are the non-cats right there. There's all the dogs are outside of the non-cats. I mean, all dogs are non-cats. They're not in the cat circle, right? They're not in the cat circle. All dogs are non-cats. So no dogs are cats, and all dogs are not non-cats. It means the same thing. Think about it. What is a non-cat? It means everything but it's a cat. So to say that all dogs are non-cats means no dogs are cats. All dogs are everything, but they're not cats. Okay? Whatever else they are, they're not cats. So that's why the middle portion is shaded, because it's saying there are really no dogs. To say all dogs are non-cats means the same thing as saying all dogs are outside the cat circle. Okay? So they're non-cats. The I statements, similarly, some dogs are black. Okay, so we put a little X in the middle so that we see dogs and black things. There are some dogs which are in the circle overlapping the black things. And so if you say some dogs, to change the quality, you say some dogs are not non-black things. That's what the obverse is. When you change the quality, so if you go from some dogs are to some dogs are not, and you go from black to non-black things. So what does that mean? Well, this is dogs, this is black things, and some dogs are not non-black. It's a double negative. It means some dogs are black. So there you put an X there in the middle again. All right. And finally, with the O statements, um, uh, some, let's say, some dogs are not beagles. Let's say some dogs are not, um, not black. Let's say some dogs are not black, because we know some dogs are not black. So to diagram this, we'd put the X. I guess you can't see it. Hold it up here. To diagram this, you'd have to say that some dogs are not black, meaning that there's some dogs that are dogs, but they're not in the black category. And the opposite of the obverse of that would be some dogs are. I can't even. My handwriting is getting worse. I'm sorry. some dogs are not okay. Some dogs are not black, and some dogs are non-black. I don't know if you can read that. So the original statement is some dogs are not black. The obverse is some dogs are non-black. You change the black to non-black. So what does that mean? Well, some dogs are non-black. It means same thing as some dogs are not black. So when you diagram it, it's exactly the same. So I admit that all these double negatives can be a little bit confusing at times, but if you think about it, just remember a double negative is a positive. So if you say some dogs are not non-black, it means some dogs are black. So when you have the obverse of any categorical statement, then you can know that the obverse has the same truth value as the original statement. All right, so you just know that. That's something that philosophers and logicians have worked out over the centuries, and it works. It's true. Now, logic is very important to our life. I will say that categorical logic, the one shortcoming, and not to be rating on any philosopher's parade, but one shortcoming is that these things only are meaningful if you have absolute certainty that your statements are true or false. If you don't know, then you're pretty much stuck with the inductive reasoning. You have to work it out for yourself, experimentation and observation. But if you know something is true or false, then through all these different uh, transformations, you can figure out whether these other alternations of the statement are true or not true. You can see immediate inferences from knowing which statements are true, which statements are not true, which converses are true, and so forth. Now, the last one I'm going to talk about is contraposition. Now, here's the thing about contraposition. It's not that hard. What you do is you switch the terms, but replace them with the term complement. Okay? That's what you do in contraposition. You switch the terms and replace them with their term complement. So, for example, I guess I should write that there. Switch the terms. And replace both with their complements, with the term complements. So if we take, okay, what should I do here? I think I'll start with the A statement. You're going to find out that as in the converse, the E and the I the converse had the same truth value as the original statements, E and I. In the obverse, they all have the same. Now with the contrapositive, you're going to find it's the A and the O which have the same truth value. So I'm going to go to A and O. So again, all dogs are mammals. And we write this out here. Dogs, mammals. And we say that this area is shaded because all the dogs are in the mammal area. And if we say all non-mammals, it's a little complex here at times, but all non-mammals are non-dogs. What does that look like? Okay, so here's the mammals, here are the dogs. The non-mammals are the things outside the mammal category, and that means all non-mammals are also non-dogs, so there are no dogs outside here in the non-mammal area. So that means all the dogs are inside there. So that means that the A propositions, the contrapositive of the A statement or the A proposition is identical to the original statement. Now, if we take the O statements, you'll find it's the same thing. So let me see. I use the trained dog thing again. Some dogs are not trained. So here's dog things, here's trained things, and some dogs are over here. At least there's one dog which is not trained. And then the counterpositive of that would be some non-trained things are not non-dogs. Okay. There's dogs and there's trained things. So some dogs are not trained, and some non-trained things are not non-dogs. Okay, again, as I said, when you have a double negative, the double negative is a positive, so some non-trained things are dogs. So over here, you put an X again, so there's some dogs in that non-trained area. Okay, so the A and the O, the contrapositive has the same truth value as the original statement. Now, for the E and the I, it's not the same. So draw a line here, not the same. Okay, for the E, if you say all dogs are, or no dogs are cats, E is a no statement, no dogs are cats, then the opposite of that would, or the contrapositive of that would be no non-cats are non-dogs. Okay, so first of all, no dogs or cats, we shade the middle to show that there's no overlap between the dog category and the cat category. And then for the no non-cats, this is a very difficult, this is a little bit mind-boggling here, I think. What is a non-cat? Well, a non-cat is everything outside of there. And what are non-dogs? Well, non-dogs are everything outside the dogs. So to say that there's no non-cats are non-dogs, there's nothing. There's no non-cats and there's no non-dogs here. So it's easier actually if you think of it in terms of the I statement. So let me get on to the I statement in a minute, because that makes it a little bit easier to understand. It actually is a little bit clearer. If you say, for example, what's my some cats are hairless. I'll put a C there for cat. Some cats are hairless things. You know, the skinny cats with no hair. There's a C, there's the H. There's some cats here. But if you say some non-hairless things, in other words, some hairy things. So these are hairless. The hairy things would be outside here, and there are some hairless things which are also non-cats. So there's some hairless things in the non-cat category. Okay, that means this is cat category, and this is the non-H category over here, non-hairless category. And so there are some things which are hairy, which are not cats, which is very different from this thing. Some cats are hairless, and some non-hairy things are non-cats. So the same thing with the no dogs or cats. So no non-dogs are non-cats. There's nothing in the okay, I forgot to write this one. Some non-H are non-cats. So so some non-H are non-cats. You have this X out here showing that there's something there which is not hairy, but here you have no non-cats are in the non-dog category. So there's nothing. This is all non-dog and this is all non-cat, but there's nothing there. So that's why that thing doesn't look anything like this. And this one, the O doesn't look anything like, I mean, the I, contrapositive of the I looks nothing like the original I, and the contrapositive of the E looks nothing like the original E. So therefore, we can say, from the point of view of the Venn diagram, that these things have, there's the undetermined truth value. So again, the A and the O have the same truth value, but the E and the I do not. Now, for those who have not studied logic before, this terminology can be a bit confusing because there's so many subjects, S's and P's and A's and B's and nons and not nons. Just remember, if you have a double negative is a positive. So if you say something, all mammals are, or all dogs are not non-mammals, it means all dogs are mammals. Okay, so that's all there is to it. You just have to remember that. Now I'm going to just summarize here once again. With the converse, or conversion, where you're switching the terms, then the E and the I have the same truth value. The A and the O do not. It's undetermined. We'll just put UND here, meaning undetermined. Sometimes it could be the same, it might not be. There's no way to know. Okay, that's conversion. So remember, E and I have the same truth value. With the obverse, with obversion, all have the same truth value. And with contraposition, again, the A and the O have the same truth value. But the E and the I are undetermined. All right? So you have conversion, obversion, and contraposition. So just remember that the A and the O here have an undetermined truth value, and the E and the I have an undetermined truth value here. So try to remember that when you get on, if you have a test or a quiz or something. The immediate inferences are not available here. If you make them, you would say that was a, illicit contraposition or illicit conversion. All right. So I don't know how much this helps. I hope it helps for those of you who are studying logic. This is my little attempt to make clear some of the things regarding categorical propositions. And some of this will be helpful if you go on to study categorical syllogisms. But I hope this will be of value to any of my students or anybody else's students who might be using my videos. All right, as I said before, stay safe, stay healthy, and have a great day.